Welcome to Chapter 14. This is still Section 2, and this is just our little special part on ray diagrams. So what we're going to do is we're going to look at how we use ray diagrams now to find the position of an image by either type of lens. Okay, and we've already talked about how to identify as real or virtual, so I'm not going to go as much into that. I also want to point out that while I'm going to talk about both converging and diverging, you really should pay more attention to the converging part. This is more for just interest, but converging is the one you need to know how to do. So as we look at it, your book lists out the rules for drawing ray diagrams, okay? So this comes directly from your book, and the way that you draw them depends on whether it's a converging lens or a diverging lens. So there's always going to be three types of rays that we use to draw to find the position of the image. Okay, we're going to draw a parallel one, a center one, meaning it goes through the center of the lens, and a focal ray that goes through the focal point of the lens. It's also important to remember at this point that diverging lenses have a negative focal point, and converging lenses have positive focal points. And that's kind of its more important focal point, but really they have them, both of them have it on both sides of the lens, as you will see. So let's take a look at our focal here. So I've already kind of drawn out the situation to make things go a little bit faster. So our example says, using a ray diagram, find the position and height of an image produced by a camera lens with a focal length of 5 centimeters. So you notice I've already highlighted that here. And I drew two lines under this one here to indicate that this is the positive focal point. So when we're talking about drawing lines through the focal point, that's what we'll talk about. Okay. Our image is 3 centimeters tall, 12 centimeters in front of the lens. I have drawn this to scale, and to use ray diagrams, you do need to use graph paper or a ruler and draw it to scale. And what I did here is each of these, if you see, goes 1 dot, 2 dot. Each 2 dots, like this range, is equal to 1 centimeter. So that's the scale that I used. And I'll write that up here for those of you who care. So 2 points equals 1 centimeter. So now as we do this then, okay, the first kind of line that we draw is one that's parallel to the axis. So what that means is I draw a line here parallel until I get to the lens. When I get to the lens, then what happens is if I had a ruler, my lines aren't going to be perfect here, is once I hit the lens, then I'm going to draw it through this other focal point, okay? So I would come down here, draw a nice straight line, and that would essentially go on forever. I don't know where it will end yet, okay? Again, always use a ruler. Mine won't be quite perfect because I can't use a ruler when I'm drawing on this. The next line goes through the center, and when that means center, it means the center of our lens. So I'm going to draw it through that point there. And again, we got to draw a nice straight line. Okay, so this is going to be kind of hard for me to do here, but we'll see how close I can get, and it will keep going. Okay, so it comes out approximately there. I probably should have drawn it a little bit higher. And then the last ray goes through our focal point on this side of the lens. Okay. And then when it hits the lens, it goes straight. Okay, so it's going to go through the focal point here, and then it's going to come out and go straight. Okay, so see, because I didn't draw it with a ruler, it didn't come out perfectly, okay? But roughly it's somewhere in this length area, okay? So then we would have an image that would look something like this, and I'll draw it with blue. Blue here would be our image. Okay, and it'd come out to whatever point this is. So here we can see that it's inverted, okay, because it's upside down from what I drew it. Okay, we know it's real just because this is a converging lens and I'm outside the focal point. Okay, and I'm outside 2F, so this should actually be a little smaller, and even with my imperfect drawing, it does come out smaller. Now, if I'd drawn it perfectly, we could actually measure the heights and calculate it using our magnification equation. Okay, but we're not actually going to do that. I did calculate it earlier, though, and our magnification should be roughly 2/3 the height. Okay, so I'm a little bit off. If I was drawing it perfectly, it would have come out to this height based on our scale. So it was a little bit off there. But again, if you had a ruler and drew it perfectly, you would get the correct thing. And even drawing it imperfectly here, I did get pretty close. So that's basically how you draw a converging ray diagram example. So next we're going to look at a diverging example, and it's a little more complicated, which is why I don't expect you to really learn it, but I still want you to see one so you can kind of understand what's going on. So again, I've already drawn the situation. This time I'm using one of these big blocks, okay, or 3 points equals 1 centimeter, okay. Because I know that because this is a diverging lens this time, my image is going to end up being on the same side as my object, so I didn't need as much space to do it. So, and again here, our focal point that matters is on this side. This is our key focal point because it's negative f, but like I said, diverging is a little more complicated. So we have a 2 centimeter tall image that's 10 centimeters in front of the lens. So again, what we do is we draw a parallel ray. Okay, we'll always have a parallel ray. Okay, but this is a diverging lens, so we know that this ray will actually go away from the focal point on the other side, but it will look like it's coming through the focal point on this side. So I'm going to draw a dotted line here and then a solid line here. And this is going to be a little harder for me to draw accurately. Okay, but I can kind of imagine that the solid ray would come like this, and that's where our light actually goes. But we're creating a virtual image, and it will kind of go like that. So that's our dotted line. Okay, so then the next one, okay, is our center line. And our center line will just kind of go straight through. So it will start here, it will go to the center of the lens here, and it will just keep going. And that just naturally diverges and goes away from that one. So drawing that one here as carefully as I can will be something like that. Okay, again, it's not perfect, but we get the right idea. Okay. And then the last one is a little bit trickier because this is the one that would go through the focal point. So on a converging lens, we would draw it through this focal point, but this is a diverging lens, so I've got to draw it through this focal point, okay? So I'm going to get a line that goes there, and that's where the actual ray travels, is through that focal point and on. But what's going to happen that we see is that when it goes through that focal point, it's actually going to reflect back here, and we're going to get a virtual ray that comes back. Okay, and it should actually meet roughly where these two cross already. So if I draw that line, this one's going to be much more difficult for me to draw because it's a long straight line. But you can imagine it's going to go something like this all the way out, and then my virtual line will come back here. Okay, and it would go like that. Okay. So when I do that, you can see all 3 rays do meet at this point here and create me a little tiny image. Okay, so that is the way that a diverging lens can create an image. So like I said, you don't have to read and remember exactly how to do this, but I did want you to see how these images are created. Do focus on the converging lens and understanding that one a little bit better. We will have a chance to practice this in class, so you can ask me questions then. I will see you there.